So, in case of rigid body motion, we have a container filled with some fluid and we take a parallelepiped of dimension dx, dy, dz in a Cartesian coordinate system of x, y, z. Now, if we have a pressure at the centroid, then we can find out the pressure force on the left hand face, pressure force on the right hand face, pressure force on the top face, pressure force on the bottom face, pressure force on this face and pressure force on the back side of this force. So, as far as fluid static is concerned, we have developed the pressure equation in which we found that del P over del x is 0, del P over del y is equal to 0 and del P over del z is equal to minus gamma. This thing we discussed when we derived the pressure equation, right. In that case, we did not consider the acceleration in x, y, z direction, and we know that acceleration produces what kind of force? That force is known as a body force, and the forces which acts on the surface is known as surface forces. So, at surface we have a force due to pressure. So, how do we find out the pressure force on the left face and right face? Though we have discussed, but let me again repeat it. If pressure at the centroid of this parallelepiped is P, then with the help of Taylor's expansion series we can find out the pressure on the left hand side. So, pressure on the left hand side is equal to P minus, because we are moving in negative y direction for given Cartesian coordinate system which we have chosen as x, y and z. So, P minus del P over del y. What is del P over del y? Pressure gradient in y direction. So, P minus del P over del y multiplied by distance travelled in that direction. So, what is distance travelled? Is equal to delta y divided by 2, because we have a centroid here. So, from centroid we have moved only half distance. So, what is the pressure? Del P over del y multiplied by delta y over 2. So, if we want to write the pressure on this side, then it will be equal to P plus del P over del y, which is gradient in y direction, multiplied by delta y divided by 2, and we are removing the higher order term. Similarly, we can find out the pressure on the right hand side of the face. On the right hand side of the face, pressure will be equal to P plus del P over, sorry, here we have a minus sign because we have moved in minus direction. So, this is minus, kindly correct it. P minus del P over del y into delta y over 2. On this side, pressure will be equal to P plus, because we are moving in the right direction, which is positive y direction. So, P plus del P over del y multiplied by delta y over 2. Similarly, we can find out the pressure force on other faces, and after knowing the pressure force, we can find out the body force. So, what are the different body force acting? One is the weight. Weight is acting through the centroid of this volume, which is equal to dx, dy, dz multiplied by weight density, right. Then we have acceleration in x direction, y direction, z direction. These acceleration will also produce force in x direction, y direction, z direction, and which is equal to mass into acceleration in x direction ax, mass into acceleration in y direction ay, mass into acceleration in z direction az. So, here we have written what is the body force in z direction. In z direction, what is the body force? It is written here. At the centroid we have P. So, at this point we are moving in a positive z direction. So, P plus del P over del z into del z over 2 multiplied by corresponding area of this face. Now, we know that why we have these arrow acting in this direction, on the bottom face we have arrow acting in this direction. We have studied that whenever pressure force is applied, pressure always acts in such a manner so that it compresses the fluid. That is why we have the arrow acting in such manner which are compressing the fluid. So, for delta FSZ, FSZ stands for Fs stands for surface force and Z stands for direction, right. So, what is the body force acting, sorry, what is the surface force acting in Z direction is equal to this force P minus and minus this force in positive Z direction. So, we have written here P minus del P over del Z into dZ over 2 multiplied by corresponding area minus P plus del P over del Z into dZ over 2 multiplied by corresponding area is equal to minus del P over del Z into dx dy dz. Similarly, we can find out with the help of same principle, we can find out the surface force in y direction, we can find out the surface force in x direction. When we can find out the surface force in x direction, surface force in y direction, then we can find out the net surface force acting in on this fluid element. On this fluid element we have forces in x direction, y direction and z direction. So, we can write minus del P over del xi plus del P over del yj plus del P over del zk is equal to, this may be written in the short form, minus del P dx dy dz.